Hello, my name is Mohammed Hamza. I'm a student from Universiti Teknologi Petronas, currently doing my studies in electrical and electronics engineering. At the moment, I'm doing my internship in virtual instrument and system innovation in Berhad, specifically in the subsidiary company, which is Visinergy SDN BHD, which is one of 3 subsidiary companies that the parent company has. Visinergy Virtual Instrument and System Innovation SDN BHD is a company which majors in developing and integrating engineering systems and solutions for their clients. They mainly use NI software as the core, NI software and hardware as the core of the company. It received the Alliance Partner Silver status by National Instruments, as well as being nominated by National Instruments as a finalist for the category of 2014 Alliance Partner of the Year for Emerging Market segment across the globe. One of the other subsidiary companies are Universiti Tech and Visinergy Agriculture with Visinergy SDN BHD, which each develop systems and solutions in their respective fields. Some of the products made by Visinergy SDN BHD are products like Data Acquisition, which is a custom data acquisition platform, modular and customizable platform for various applications, as well as the Visizo Grade, which is a fruit ripeness system which checks fruits for different types of ripeness. As an intern in Virtual Instrument and Visinergy SDN BHD, I have certain roles and responsibilities. My roles and responsibilities are to participate in product, service, and process development, participate in benchmarking, test competitive product to gain relevant information, as well as programming, installation of devices, and research and development. In my first 2 weeks, in my first week in Visinergy SDN BHD, I was asked to do self-learning on LabVIEW. Now, what is LabVIEW? LabVIEW is a platform, is a software made by National Instruments, which is used as a system design, which uses as a programming software, which uses the G programming language, which is a graphical programming language. It's based on data availability, whereas if the required number of data is available to a function, then the function will execute. It uses block diagrams and shapes and lines to connect them, so it's almost like designing a circuit, but it's a program, which is very different from the programming I'm usually used to at my university, which we use like Python or MATLAB or C programming. This was more of a graphical programming, as we can see the block diagrams and the lines, and we can see where the information is going into and out of, which was very weird at the beginning, and it looked like it's hard, but thankfully Visinergy has multiple videos on YouTube explaining block diagrams and explaining how to use LabVIEW, as well as tutorials to test ourselves and simple projects that a student like me can do to increase my experience on LabVIEW. In my self-learning on LabVIEW, I was able to create a digital clock, and it will be viewed, you can see the block diagram and the front panel of it. Then in my weeks after, I was asked to switch from LabVIEW and focus more on NI Multisim. Now, NI Multisim is a software also made by National Instruments, which is used to design circuits and design printed circuit boards. I learned a little bit about Multisim from my university, as we used it for designing circuits, but we used the online version, which has way less function and is less complicated than the actual software, the full software that was provided to me by my company. I did self-learning on Multisim. I was able to design a traffic control traffic control circuit simulation using a microcontroller on Multisim. And after that, my supervisor gave me my project, which is to design a Raspberry Pi hat. Now, a Raspberry Pi hat is a hardware that contains many components that increase the features offered by the original Raspberry Pi microcontroller. And according to the Raspberry Pi hat project that was given to me, it was given to me with more requirements. It can be seen on the screen, but the requirements, to briefly, is 2 input channels of 24 to 3.3 volts digital level translator, as well as output 2 channels of Raspberry Pi, output 2 channels from 3.3 volts to 24 volts, controlled and safe digital output, as well as 2 input channels of 0 to 10 volts of analog to digital converter, as well as 2 output channels of digital to analog converter from 0 to 10 volts DC. So after I received my requirements, I went ahead and did my research. As I was in the research and development department, I did research, and I was able to design a circuit for each requirement, a circuit simulation for all the input channels and all the output channels. And I received the results, and after my results were accepted by my supervisor, I went on ahead to create the printed circuit board. Now, after combining all the different circuits that perform different requirements, I combined them into a big circuit that does everything, and I replaced the components with the components that have footprints. Now, one of the problems I faced during designing the multi-sim circuit, the Raspberry Pi hat circuit, was for the analog to digital converter. I wasn't able to find the analog to digital converter that I chose to use. So I had to learn the skill of creating a component on multisim. Now, creating a component is basically using one of the components that is in the database of multisim and changing the pin configuration and the footprint to match the one that I chose online. And the steps in component creation multisim is entering the component information, selecting a footprint and the component configuration, selecting and editing the component symbol, as well as setting pin parameters, mapping the symbol pins, selecting the simulation model, mapping the symbol pins, and saving the part in the database for later use. After learning the skill, I was able to create a mirroring component for the analog digital converter that I chose on multisim using their own component, and it was verified by my supervisor. The next step in the process was to transfer this big circuit into a printed circuit board, which is also called a utility board. Now, in this part, I faced many requirements, as I needed the circuit that I made, the printed circuit, to match the sizing of a Raspberry Pi hat, which I found online, and it has certain requirements for the size. Also, I needed to fit all the components that I chose into that same size while putting the components in advantageous positions for the user to be able to use. So when I went into the printed circuit board version, I put the size in, and then I had to create the holes, which are in measured size. I had to check the measured size of a Raspberry Pi hat as well as the Raspberry Pi, to be able, so the Raspberry Pi will fit on top of it. Also, the boxer head needed to be in the right position to be able to be fully connected to the Raspberry Pi hat, and the holes needed to match the holes on the Raspberry Pi, as well as putting the components in places where the users can easily reach, like the input and the output voltages, and places where are on the edge of the Raspberry Pi hat so that it can be reached. Some of the problems and that I faced, not problems, some of the difficulties I faced was when connecting the components on that surface. We can easily use auto place to auto place all the components on the printed circuit board, as well as auto route to route them all automatically. But if we do that, the components will be placed in random positions, and the route, it will be easier, but the components will be put in random positions. So I had to place all the components in the places that I wanted to, and then route them myself, as auto route will not route everything because I didn't auto place them. So I had to figure some troubleshooting skill. I had to learn some troubleshooting skill in designing circuits, like using VIA and how to manipulate the copper lines on the printed circuit board so I don't get a short circuit, as well as refining the lines so that they don't have sharp edges that will reduce the efficiency and cause problems in the printed circuit board. So the final printed circuit board, after I finished all the routing and tested it and everything, can be seen right now. And then a 3D view. Multisim also provides a 3D view that will be shown right now, of the top view, the side view, and the bottom view of the Raspberry Pi. Also, now you can see the components that I used in this project, all the different components that I used in this printed circuit board. In conclusion, at the end of my the 3 months at the end of the first 3 months of my internship, I was able to understand and obtain more insight on how businesses operate and act during my 14 weeks at Visinergy SDN BHD. Also, I have gained more experience on LabVIEW programming software. I have gained more experience on multi-sim software. I have gained experience in designing circuits and printed circuit boards, and I honestly feel like I can design any circuit that is required of me that can be that can be used, ranging from a solar panel system into a rocket ship system. And I was also able to see how a workplace functions and how the engineering industry operates and where it's headed. I would like to thank all the engineers at Visinergy for helping me during my internship with all the questions I had, with all the problems that I had, and giving me different solutions and different point of views on the problems I was having and the solutions I can use. I would like to thank Visinergy for taking me in as an intern and helping me gain more knowledge to use later on in my degree and in my job after I graduate. As of how this relates to my university studies, I'm an electrical and electronics engineering student, and LabVIEW and multisim and all this stuff is mostly used in control and instrumentation, which is one of the majors we have in electrical and engineering bachelor's degree as to choose from as one of the majors. So it definitely helps me if I choose that major, and it also helps me in understanding more on how all the other majors connect to each other. And in designing circuits, that definitely helped me on the electronics major on how to design circuits and be able to get a perfectly designed printed circuit board that can be used in any machine. I would like to thank Visinergy and Virtual Instrument and System Innovation for accepting me as an intern and helping me learn and giving me more experience in the field and more experience on more softwares. Thank you.